Hello everyone, myself Dr. Abhishek. In earlier lectures, we have discussed about plate tectonics, continental drift theory and the phenomena which are associated with these, how these are responsible for the movement of the plates, and subsequently because of increase in the stresses along the plate boundaries and same phenomena will be applicable to within the plates, there will be development of earthquakes. When these earthquakes happen, there will be different kinds of waves generated at the focus or at the source of the earthquake, and these will travel from the focus in all the directions away, and when these are interacting with the material, that is the crystal medium along the propagation path or through different soils, there will be phenomena of amplification, de-amplification which will be happening in different frequency of waves. In today's lecture, I am going to give you an overview about one important phenomena which is primarily important as far as the safety, as far as the casualties, as far as the loss of infrastructure, connectivity and many more such informations which are relevant in order to ensure what will be the damage scenario primarily during an earthquake is landslide. As we know, significant portion of our country is prone to landslide occurrence. Every year during whether it is rainy season or during major to great earthquakes, there will be information on landslide occurrence in different parts of the country. If you talk about northeastern part or in other parts like Western Ghats and other parts of the country which are particularly in hilly terrain, often we hear the news that during such particular earthquake or during prolonged rainfall, a piece of land has been slided and triggered lot of landslide, blockage of roads, sometimes toppling of the vehicles, and worst scenario it can even lead to casualties. So today's lecture, because it is also an induced effect of earthquake, as we discussed earlier also, we will be talking about different induced effects. That means whenever earthquake generated waves are interacting with the system, whether it is layered surface on level ground, whether it is saturated ground subjected to loading because of the passage of waves, or whenever the sloping ground is there, though it looks stable in its static condition or in routine, but because of prolonged rainfall or because of additional loading which are generated because of the waves during an earthquake, these can destabilize that particular slope and finally it will lead to landslide. So in today's topic, that is lecture 27, we will be discussing an overview about what is landslide and how one can classify the landslide. Please understand, the topic of this particular lecture is not to help in understanding how to quantify the landslide hazard, because that is again a vast topic and that is not the syllabus of this particular course, but I will be giving you an overview about what is landslide and how, because different materials are there, depending upon the material which are involved, you can classify the landslide. And next time whenever you see any particular slide, depending upon what geometry available, what physical properties are available, what material has involved in that particular kind of failure, you will be able to understand what kind of landslide has occurred on a particular site. Sometime it can be one material which has undergone failure, sometime it will be more than one material which has undergone failure. So here we can see an introduction about landslide. So generally we use landslide as downward movement of material which was existing on a slope, primarily the rocks. If you go to hilly terrain, there are no soil available on the surface, you will have rocks. At times you will be having weathered rocks, even soils also, or combination of rocks and soils, and even at some location you will often encounter organic materials getting deposited over a period of time, and there are hillocks, mounds and even big hills are also there. So what if material which is the hill is composed of undergoes failure, subjected to downward movement, that is called as landslide. photo which is given on the right hand side, you can see here it is not simply the slide which has happened along a particular slope, but depend upon the geometry, depending upon the characteristics of the failure, there are different components as you can see over here. So, the top portion which is given over here, that is the crown, that is the topmost portion through which, after which if you come down further, there will be failure you will experience along the slope. Then there will be main scarp, that is the failure or the slippage which has happened in a significant portion just after the crown. After that, as you move towards the toe, there will be significant signatures of failure along the surface of the slope. So, you are having crown, then you are having a main scarp, that is the main scarp means the main projection which is indication of some kind of failure which has happened along the slope. Then you will come across minor scarp, so there will be relatively, in comparison to main scarp, there will be deformation, but those deformations will be relatively smaller and there can be more than one kind of minor scarp. Then you can see subsequently the failure of the material along the slope, that will also lead to development of cracks along the slope. Depending upon the nature in which the material has undergone failure, you can have longitudinal cracks also, you can have signature of material undergoing rotation, undergoing toppling. So, that will also happen along the cracked surface. So, what it indicates, there was a slope which in its initial condition was quite leveled, just like you can see on this particular side, the slope is quite stable, but you have another significant portion of the slope which has undergone failure. So, you started with the crown, which is the topmost portion, then a significant portion which along which the material has undergone downward movement, that is called a main scarp. Then you are having original ground surface with respect to which you are actually measuring how much is the displacement along the slope or in vertical direction has happened along the scarp. Then significantly you will have more than one minor scarps. Then there will be development of cracks along the fault length, along the slope. Then there will be toe. So, just like our feet, there will be a toe along which the material which is undergoing failure from the crown and along the failure surface has started gathering. Now, again you can see over here the entire material which has undergone failure has actually started showing some kind of rotation or some kind of slip or some kind of movement along this surface. For that reason, this particular surface, it is called as rupture surface. That means the material which was undergoing failure has actually taken this particular surface. It is not in one dimension, you can see it is moving along the slope and also parallel to the slope. So, if you are seeing from if you are seeing on the screen, so it is along the line of sight. So, it is actually a plan, that is why it is called as the surface. So, rupture surface is actually the surface along which the material in 3 dimension has actually moved, and this is the actual material or the body of the material which has undergone failure. Again, you will see often some material which has undergone failure, it will start failure from the surface, and then once it reaches to the toe or just before the toe, the material will reach to its natural slope or initial slope. This can happen over here, this can happen slightly downward also, and accordingly one can classify whether it was slope failure, toe failure, surface failure or base failure. So, depending upon what is the position of the failure surface with respect to the toe, the landslide can be classified. Then again you can see the feet which is visible over here, which is the end portion just before the toe. So, this is the typical nomenclature of different parts of a failure which has happened to the slope indicated by the landslide. And whenever we are discussing about this cracked material, whenever we are discussing about the material available on the main scarp, material available on minor scarp, there will be soil, there will be rock, there will be organic material, there will be combination of different kinds of material. Not every time you will have homogeneous material, you can have different combination of the material, because if you consider the slope, whether it is man-made slope, whether it is natural slope, also taking into account what are the weathering and depositional agencies which have been dominating in this particular region where this particular slope is available, that will also help in understanding whether the material along the height of this particular slope will be relatively homogeneous or there will be varieties of material which you will find across different sections of this particular failed slope. So, depending upon the process involved, the formation of this particular slope, that will define what will be the characteristics of this slope. Subsequently, the process, if the process is very slow, there are more chances that the material which is deposited in this particular slope, that will be relatively stiffer in comparison to the material which is exposed to lot of weathering and has been deposited in a relatively quick time or small span of time. So, that is going to give you some indication about whether it is a natural slope, whether it is a man-made slope, whether the material at the slope is homogeneous, the material at the slope is heterogeneous, the material is single type, means throughout it is soil, or it is rock, or it is organic material, or it is a combination of organic material and soil, organic material and rock, or soil and rock. Thirdly, whether the material is relatively stiff in its in situ conditions, or the material is relatively weak such that it is almost at the brink of failure, or the slope is almost waiting for any triggering mechanism and suddenly the material will undergo failure by movement of by downward movement of the material. So, partly we have discussed about typical parts of the slope or landslide, that is crown, then main scarp, then head, then main body of this failure, then foot, then toe, and then the surface of the failure. Surface of the failure, as I mentioned over here also, depending upon where the surface of the failure is interacting with the original ground surface, you can categorize whether it is a toe failure, whether it is a surface failure, whether it is a base failure. So, this is a brief overview about what is landslide, that is downward movement of the material along a particular slope. There can be a number of triggering mechanism. As I mentioned, it can be primarily because of rainfall, if the rainfall is continuous, or the resultant of occurrence of rainfall has created some weaker planes along the particular slope, then there are more chances the slope will undergo failure. Secondly, there is lot of disturbance, vegetation has been cut off from the particular slope such that the vegetation or the roots of the plants were keeping or holding the slope back in its position, that can also lead to failure. Thirdly, because of earthquake induced loading, there will be vibration which will trigger additional load on the material which was on the brink of failure, or the material otherwise was in stable condition, but because of this additional disturbing force the material has undergone failure. So, the importance of different kind of restoring forces, different kind of disturbing forces you can come across when you study about slope stability. So, there it will be very clear what are the possible components which are leading to failure of the slope, what are the components which are leading to restoring the slope against any kind of failure. So, landslides are classified into different types, primarily depending upon the type of movement and the type of material involved. As I mentioned earlier also, not every time you will find a slope having the same signature that the material was there in its in situ condition and then the material started failing, or depending upon the movement. So, sometime you will see the material is simply falling from the slope, you will see sometimes the material is flowing like a slurry, at times you will see the material is undergoing some kind of rotation, material will undergo topple, material will undergo lateral spread. So, each of these phenomena, the outcome is failure, but how this particular failure has occurred from its initial position of the slope to the final failed slope, that will be defining what is the kind of landslide, what is the type of landslide which has happened at a particular side, and then depending upon the material involved you can say it is rock failure, it is soil failure, or combination of those. So, depending upon the type of movement you can classify landslide. Again, depending upon the material involved, you can classify the landslide. So, material involved in landslide are primarily soils and rocks, because if you are talking about hilly terrain, you may experience intact rock, you may experience weathered rock, you may find some weaker planes along which there are possibility that the rock will undergo movement. Then there may be some cracks along which precipitation or because of freezing of the material there will be additional loading which are getting generated. And same in terms of soil, because of prolonged rainfall, because of precipitation, because of problematic material where the soil comes in contact with the problematic material, it may weaken the soil or it may cause some kind of localized channel along which possible movement in the soil is possible. Finally, as this particular phenomena progresses, it will lead to failure in a particular slope that will be witnessed in forms of landslide. Often we will see failure when you are moving along a particular roads. Sometimes you will see some boulders started moving from the top of that particular slope, falling on the road, sometimes falling on the vehicle, sometimes moving and further it goes down. Primarily when we are traveling along the hilly terrains. So, that is one kind of another failure which is very prominent in case of landslide, particularly in rocky terrain. So, soil often is described as earth, which is composed of sand sized particles and other finer particles. Whenever it comes to debris, we are discussing or indicating some kind of coarser material which is not of sand size, but coarser than sand size. So, whenever we are talking about earth, we are mainly referring to finer material. When we are talking about debris, we are talking to bigger material. And of course, there are movement of the boulders also, which at times you can witness rolling down primarily along the slopes. Depending upon the type of movement which is happening during a particular landslide or during a particular slope failure, you can call it as primarily into 4 types which are shown on the screen, that is falls. Again, depending upon whether it is falling of the material directly from the top, you can call it as rock fall. If the material is undergoing toppling while detaching from its parent material, you can call it as topple. So, both rock fall and topple are the categories of fall kinds of landslide. Then you can have spread, as the name suggests. So, the material along the slope will experience lateral spread. As the material is going down, it is also spreading in a lateral direction. So, often you will see there was a slope which has undergone failure, and at the toe of the particular slope you will see the material is all spread along the length of the perpendicular to the failure surface. So, that will come under lateral spread. The third one is slide, as the name suggests, and as we have seen in the previous figure also, slide means material was there in equilibrium, but because of some reasons now the failure has happened and the material has undergone some kind of sliding. So, material was there and then it has undergone sliding. When we say sliding, generally there will be a failure surface or the surface along which the sliding has happened. So, you can call it as rotational landslide or translational landslide. The last one is flows, as the name suggests. So, here unlike spread where the material is undergoing failure in terms of lateral spreading on its own, in case of flows the material will be mixed with respect to water, and then in terms of slurry the material mostly will be flowing. So, you can call it as earthen flow. The material will be actually undergoing failure, continuous movement of the material along the flow will be happening. Then debris flow is also possible, and then as I mentioned, at times water will be mixed with the material and it will be flowing just like a slurry. If the parent material or the debris are of volcanic origin and has been deposited subsequently, if such material is undergoing failure, you can call it as lahars. So, that is also one category of flows type of landslides. So, the first one that we were discussing about fall, you can see over here one slope is there. Looking at the slope, we can understand the slope is quite steep, it is almost vertical, and the material which was there at the top almost in the hanging portion, in case of fall, has actually been detached from its parent's material and started vertical movement. This vertical movement most of the time will not be happening along the surface, because the hanging portion of the material will be slightly outside with respect to the original slope or the vertical ground. As a result, when the material is undergoing detachment, the material will simply drop from its parent position to the some portion of the slope, but not certainly will undergo movement with continuous in contact with the slope. So, a fall starts with the detachment of the soil or rock or both from a steep slope along the surface on which little to no shear displacement. No shear displacement means the material, because there is no contact between the material undergoing failure and the steep slope. So, you can say almost there is no shear displacement available on the slope surface between the slope and the material involved in case of falls. In case of rock falls, there will be abrupt downward movement of rocks or soil or both. Primarily, you can see these in steep slopes or vertical cliffs. So, if you see vertical cliffs and some material was there at the top of that particular cliff, by virtue of failure, the material has actually detached from its parent medium and then suddenly drop and then started moving further. Now, that drop can be depending upon whether the entire cliff is almost vertical or some portion of the slope is vertical. That will define whether the drop will be at the within the slope or it will be outside the slope. That will be the characteristics of rock fall. So, detaching of the material described by fouling, and then subsequently when the material is falling on the slope, it will further go down, because after all it is dropping on a particular slope. So, by the mechanism of dropping and further, in order to reach the equilibrium, the material will further undergo bouncing, rolling, and then it will reach to more or less stable ground surface. Generally, it is triggered whenever you will see, because vertical cliff or steep slope you will often encounter whenever there is some kind of cut made along the road slopes or along the slopes for the construction of the roads. Undercutting of the slope. So, you cut a slope and leave them in very steep positions. So, certainly the material which is there hanging on the top will undergo rock fall. Similarly, you can see this, the one just I mentioned, it is related to human related activities. At times there will be very fast movement of the streams or rivers adjacent to the ground, as a result of which there will be subsequent weathering, there will be subsequent cutting of the material, leaving the actual slope in very stable or almost vertical position. In these cases also you can often encounter rock falls. Similarly, because of differential weathering, whether it is sometime because of freezing, sometime because of thawing, also if it is happening differentially, what will happen as a result, because of these differential weathering agencies or the rates at which these processes are happening, there will be localized formation of the channels along which weaker planes will be generated, and subsequently by virtue of its position and overcoming load, these will undergo failure. Human activities, as I mentioned earlier, many a times while constructing road in hilly terrains, we often cut some portion of the slopes, make it almost horizontal and then lay roads, but the remaining portion of the slope, which many a times is the slope is not continuous, you have actually cut some part of the slope which was very close to the original toe, and then after that it is left almost in vertical position or very steep slope. There also you can see some kind of rock falls witnessed. Third part was, if there is intense vibration, it can happen because of earthquake loading condition, and subsequently if some kind of construction activity, explosion happening in and around of that particular slope, then that can also trigger additional loading and subsequently lead to failure by means of almost no to little shear displacement, which is the primarily characteristic of rock fall. So, rockfall, as I mentioned, it was one kind of failure, comes under the category of fall. Second one was topple. Now, you can see in this particular figure, it is different from rockfall, because there the material was simply dropping from a particular height and was undergoing bouncing and rolling and reaching to the surface. In this particular one, you can see the material remain, firstly it is not related to very steep slope, but you will see the material has undergone forward movement. So, you see material was located somewhere over here. Primarily, one example is given over here also, because of columnar joints in the rocks, which is possible indication of weaker planes. If some kind of additional forces because of freezing of water along this particular planes has happened, or because of earthquake loading also, which is actually generating some kind of destabilizing forces, what will happen? The material will detach from its original position. So, this particular material which has actually undergone toppling, which was actually located attached to the original ground, that particular material has now undergone failure, and this particular failure is not abrupt. This particular material is not in forms of no to little shearing, but you can clearly see the material in the name of failure is actually undergoing rotation. So, this material is undergoing rotation along this particular point of rotation, which usually will be located below the center of gravity of the displaced mass. Only then the material can undergo rotation. So, you see subsequently the material will undergo rotation, and depending upon whether it is an intact rock mass, boulder, the same thing will keep on toppling and then will reach to the bottom, or if it is composed of fragments of other material, during the course of rotation and downward movement, these material will further disintegrate into individual components and then subsequently will undergo failure as it moves from its parent position to downward movement. So, this is again toppling. The characteristics of toppling, though it comes under falls, it is significantly different from rock fall. So, if you go to a particular site and you see if downward movement directly is there, you can call it as rock fall. If the material is undergoing some kind of rotation, toppling, you can call it is undergoing toppling, provided the material is undergoing a rotation along the point of rotation. So, these can occur again in both rock mass as well as in the earth material, prevalent in columnar jointed volcanic terrains. Also, it is common where it is very steep banks and adjacent to that some rock, some river is flowing, then suddenly you will see a large chunk of material is falling from its parent position and dropping down. So, you again that is also an example of topple, which is a kind of failure of the slope. So, here we are talking in terms of the slope which are adjacent to the river banks. Generally, it is triggered by the gravity exerted by the material located up slopes from displacing mass. So, you will see the material actually in its position, in its initial position was almost subjected to some kind of external loading condition because of earthquake loading, because of prolonged rainfall, but certainly there was some weaker portion along which the material was actually possible to undergo failure, which has actually happened during topple. Same way, if there is water or ice which is actually available in this particular locations, these will also induce loading within the cracks, as a result of which it will try to widening the cracks. As it widens the crack, that means it is actually destabilizing this particular adjacent landmass. When the landmass undergoes destabilization, certainly it is already on the side of the slope, it will be ready to undergo any kind of failure, then subsequently it will undergo failure forward downward movement. Vibrations, again the material was in intact position, though it was adjacent to the slope, but was not undergoing failure, but because of vibration it induced additional loading and subsequently the material has been detached from its parent material and undergone failure by toppling. Underground excavations or undercutting. So, excavation many a times you will see the material was quite intact, but by virtue of excavation, the material in its initial position when the excavation was not done was quite stable, because it was getting its restoring force generated against this particular leveled surface. But when you remove this particular slope, the material will again be in more destabilized position, and subsequently because of this undercutting or excavation, the material will undergo failure. Excavation also can be considered if the slope was quite leveled, gentle, but because of excavation you remove a significant portion of the slope, leaving the balanced portion or the other portion in its quite unstable position. So, certainly that particular material which is now left adjacent to the slope is actually ready to undergo failure. Once it gets the favorable condition, which is primarily the external loading or the pressure generated in the cracks, that will lead to failure. Then erosion, many a times, as I mentioned, erosion which is created by the stream which is flowing adjacent to the slope, it will also cause some kind of loading to the material, and subsequently the material, a chunk of material will undergo failure. Differential weathering agencies and their rates will also lead to development of the cracks along the slope or within the material which is located along the slopes, and subsequently these will cause weaker sections through which the material can undergo failure. Slides, now you see over here, irrespective of the failure, the nature of the mechanism of failure which is shown in this particular slide, or the nature in which the material, that is the rock and the soil, which had undergone failure, it is significantly different in case of slides. So, there will be downward movement of the slope or rock mass along a ruptured surface. So far, whether it was rock fall or it was topple, there was no mention of ruptured surface or the surface along which the material is undergoing movement or the slope is undergoing failure. So, ruptured surface means the surface along which the material is undergoing failure. Initial position was this particular land mass was quite stable. This was the slope. Quite stable, quite leveled surface, but by means of some triggering mechanism, now this entire portion of this material starting from the crown to its toe, the material has undergone failure. Again you can see over here there is some section through which the failure surface will reach to the original slope, depending upon which you will say it is toe failure, surface failure or base failure. But here you can see, so when the material is undergoing failure, the material actually undergoing some kind of lateral movement or downward movement along the slope. Depending upon the material which is involved, you can have rock, you can have soil, you can have organic material, you can have. So, you can see over here when the material was undergoing lateral movement, there was development of cracks in lateral direction. Subsequently over here you can see, in addition to lateral movement, there is lateral movement also. So, one was cracks along the longitudinal direction, then you can see some cracks which are developed along the lateral direction because of variable rates at which the movement of the material along the slope is happening. As a result of which you can see even there will be development of lateral cracks along the failed surface or along the ruptured surface. So, the downward movement of the slope of a soil or rock mass occurring along the surface of the rock on the surface of rupture or relatively thinner zones. You can see over here again these are sections indicating intense shearing which is happening all along the ruptured surface. So, this was the ruptured surface along which intense shearing is happening. The shearing so far was not available, whether you talk in terms of rock fall or whether you talk in terms of topple, but in this particular case there is the field condition of the failure is an example of pure shear. The material is undergoing pure shear, or there is development of rupture surface through which the material is undergoing slight movement and going downward. Depending upon the material involved, you can have longitudinal cracks, and subsequently as you go deeper, because you see over here, when the rupture surface is over, you will see the rate at which the material is undergoing lateral movement along the slope will significantly change. As a result, there will be development of lateral cracks, or there will be deposition of the material all along this particular surface. So, this is an example of slides, which is type 2 kinds of landslides. If you talk about rotational landslide, the characteristics are a landslide on which the surface of rupture is curved upward. So, you can see over here, though it is undergoing rotation, you can see over here, it is this particular surface, it appears to be the surface of the spoon shaped. So, there is downward movement, and the surface of failure is actually coming onto some other section of the failed slope. The slide movement is rotational. You can see it is undergoing rotation, that is why it is called as a rotational failure. And the surface of rotation, or the slide movement of the rotation, is parallel to the contour of the slope. So, this is the contour of the slope, and the rotation is also happening parallel to the slope. This is generally prevalent in homogeneous soil, because if it is heterogeneous soil, depending upon whether the relatively stiff soil is there at the top or it is there at the bottom, that certainly will ensure that there are more chances the material will undergo lateral spread, or the material will undergo some kind of detachment rather than continuous failure, which is happening along this particular surface of failure. So, prevalent in homogeneous soil, that too when the slope angle is ranging from 20 degree to 40 degree. So, this is the slope angle. You measure this angle with respect to the ground, level ground surface. So, this angle, I am assuming it as delta. So, depending upon the value ranging generally in the range of 20 to 40 degree, and it is in case of homogeneous soil. That is why you see the continuous material, the entire material is continuously undergoing failure. So, there is no indication that some material is undergoing rotation, some material undergoing toppling, or some undergoing lateral spread. It is continuously sliding of the material, and it is undergoing intense pure shearing along the failure surface. Again, the rate of movement may vary from as low as 0.3 meter within 5 years, or 1.5 meter per month. So, this is the rate at which the movement along this particular slope is possible, starting from 0.3 meter. So, that is like very slow movement, 0.3 meter in a life in a time span of 5 years, to almost 1.5 meter in just 1 month. So, that will tell you it is with 1 year, one and a half month back nothing was there, and suddenly because of very excessive movement along the slope, the material has undergone failure, that triggered a landslide. Generally, these are triggered by intense or sustained rainfall, whether the intensity of rainfall is more, or even though intensity is less, but it is prolonged rainfall. So, rainfall is continuous for maybe 10 hours, 15 hours, 2 days, like that. So, prolonged rainfall, as a result of which, when the material, when the water is falling on the surface, it will actually form weaker planes along the surface of this slope, through which there will be channels through which the water is continuously moving, and these weaker planes will also make ease for the slopes or the material which is available on the slope to also start moving, because now the material which was below and above this particular channels are actually separated by the channels which are created by water, as a result of which there will be ease in terms of movement of the material along the slope. So, that is one triggering factor whenever it comes to rotational landslide. Same way, if there is snow which was deposited along the slope, but because of some reason the rate at which the snow melted, it was very fast, that will also be very much similar to prolonged rainfall, or high intensity rainfall. So, again these will also create local channels through which water will pass under the slope, and these will create weaker channels through which this will actually break the linkage, or this will cause some kind of ease between the two materials which are located above and below of these channels. Subsequently, that will push to failures. Third example is, so one is prolonged rainfall or intensive rainfall or quick melting of the snow. Then rise and drop in groundwater table. Drop in groundwater table many a times cause cracks that will subsequently trigger in generation of weaker planes. Similarly, rise in groundwater table, again suddenly it will cause maybe some material completely saturated, other material partially saturated or dry. That can also cause favorable condition in terms of failure to trigger, generally happening during flooding and reservoir filling in terms of dams. And then earthquake induced loading conditions. So, though the slope was stable consisting of homogeneous material, but if you analyze in under static condition, the restoring forces were dominating than the disturbing forces, but because of additional component of disturbing force, that is earthquake induced loading, you will get more component of disturbance. As a result, the slope which was otherwise before earthquake loading condition was in stable condition, now has undergone failure. Next one is translational failure. You can see over here, in comparison to rotational failure, where the material was undergoing rotation and was undergoing failure, the slope was undergoing rotational failure and there was creation of rupture surface through which the material was undergoing failure. In case of translational failure, you see there is no rotation, rupture surface is still there, but because there is no rotation, the material is simply sliding, as a result of which there is no curved rupture surface. The rupture surface is almost parallel to the slope. In this particular case, the mass moves out downward and outward along a relatively planar surface. So, you see with comparison to rotational failure, where the material here, entire material was undergoing failure. So, it was indicating like the slope was there, the entire slope has undergone failure, and while this rotation was happening, the material itself on the slope or along this particular surface had undergone downward movement. In this particular case, the material has simply come out and started moving laterally and downward on a planar surface. Again, that planar surface will also called as rupture surface, because along this particular surface the material has been detached from its parent material. This is generally occur when the presence of geological discontinuities such as faults, joints, bedding planes are available in the material, because these are weaker planes through which there are more ease for the material to undergo movement. So, you see over here as shown here, the material which is available over here has actually started detaching from its parent material and then started moving laterally. There is no rotation component over here, the material is simply moving along the planar surface. So, when then these kind of discontinuities are available between the rocks and the slope, the material along this discontinuity will find a ease, and that the material which is above this discontinuity will start moving along this particular planar surface. Most common types of landslide occur in any environment and condition are translational landslide. The rate of movement can vary from 1.5 meter per month. So, you see translational failure are much quicker in comparison to rotational failure. So, 1.5 meter per month to 1.5 meter per day, that is the rate at which translational failure can be triggered in actual site condition. Then the triggering factors include intense or sustained rainfall. As I mentioned, either the rainfall duration is very high, though the intensity is very less, it can trigger landslide, or the intensity of rainfall is very high, though the duration is not significantly high. Both can help in creation of weaker channels through which possibly the material at later stage can undergo failure, or if it is very intense rainfall, even during that rainfall it can undergo failure. Same way, rise in groundwater table within the slide due to rainfall, prolonged rainfall or sustainable rainfall or intense rainfall, snow melt or flooding that can again cause some kind of separation between the same material by virtue of different content of water present there. Human related settlements or disturbances such as undercutting. You cut the slope without taking into account what is the moisture content condition there, what is the material, whether the material is susceptible to undergo failure. And the last one, earthquake induced loading condition. As I mentioned in the beginning, because landslide is one among different kinds of induced hazards which are possible or induced phenomena which can be triggered or can be associated with respect to earthquake induced loading. That is the reason some introduction of landslide has been brought over here. So, every time you discuss whether it is about rockfall, you discuss about translational landslide, you talk about rotational failure. Every time there will be some component or some triggering factor of earthquake which is also possibly can induce these kinds of failures. Then the next one is spread. As the name suggests, the material along the direction of failure, it will not undergo any kind of rotation, but the material will remain intact, but will spread to larger area. So, generally it will be, the characteristics are extension of cohesive soils or rocks accompanied by general subsidence of the fractured mass of cohesive material into softer material beneath. So, as you have seen over here, there is relatively softer material and this is relatively cohesive material and relatively stiffer material. Because of this significant contrast in the stiffness of the material, there will be development of plane through which the material can undergo failure, because any kind of movement, if it has to happen in weaker material, the stiffer material will not follow the same pattern, but there will be some kind of relative movement which is indicated over here in terms of spread. So, lateral spread, it generally occurs on a very gentle slope. So, you see the slope is not very steep, but yet it is happening because the material above and the material below is having significant contrast in terms of stiffnesses. Occurs on very gentle slope or essentially along the flat terrain when the stronger upper layer of rock or soil undergoes extension. Why it is undergoing extension? Because the material below is relatively soft and is experiencing some kind of movement. This movement can be happening because of liquefaction, it can be because of subsidence, and it can be because of any other triggering factor, but because of the movement which is happening in the softer material, there will be, the stronger material will undergo some kind of extension of movement with respect to its parent material. Because it is relatively stiffer, you will see the material will be moving in its stiff form, there will be formation of cracks, but the material is simply spreading, there is no slippage happening, there is no movement along the planar surface, there is no rotational failure as was happening in case of slide in the previous slide. Generally accompanied by ground subsidence in the weaker material. So, weaker material, whenever it is undergoing some kind of ground subsidence, whether because of static loading condition and dynamic loading condition, significant change in water table, that will trigger some kind of extension or cracking in the material which is relatively stiffer and located above the softer material. The triggering factor in this particular case include liquefaction induced by earthquakes, natural or anthropogenic overloading of the ground above unstable slope, saturation of underlying weaker layer due to precipitation or snow melt. Many a times, because most of the time these hilly terrains are located higher altitude, many a times you will often encounter landslides happening along possible formation of snow. So, whenever there is melting of the snow happening at very fast rate, that will also cause weaker channels. Subsequently, there will be formation of failure surface along this weaker channel, which will subsequently lead to failure. of the slope itself. The next is saturation of underlying weaker layer due to precipitation and snow melt. So, precipitation again because of prolonged rainfall you can have, or because of very quick snow melt you can have formation of saturated weaker layers in the softer material. As a result of this weaker layer, the above material, which is relatively soft, will undergo some kind of extension or spread. Last one is plastic deformation of unstable material at depth. So, that because it is undergoing plastic deformation, certainly the material which is above this particular weaker layer will also show some kind of movement, though it is not elastic movement. You can see the material has been detached in small fragments and have started moving, or later spread has happened in the relatively stiffer material. The next one is flows. So, initially we discussed about fall, where we were having rock fall, the material is simply dropping, then we were having toppling. So, material after getting detached undergo some kind of rotation, and along the point of rotation which is located beneath the center of gravity of the displaced material, the material undergone rotation and subsequently it may remain intact or it may be broken into smaller fragments. Then we have slides, the material was undergoing failure along the failure surfaces, then we had spread. So, material though it is undergoing failure, there is no movement or development of shearing within the stiffer material, but it is simply disintegrated into its small fragments and then started moving downward over a relatively softer material. The last one is flows. As the name suggests, the material in this particular case will start flowing. So, there will be continuous movement of the material along the particular flow, along the particular surface, and unlike the case of spread, which is even possible in case of gentle slopes, here the slopes are relatively steeper. So, flows are spatially continuous movement of material in which the surface of shear are short lived or closely spaced. So, you can see over here there are surface through which the material, when it is subjected to debris flows, mud flows, the material along with the water has actually been mixed together and then started continuous movement in terms of the flow which we see in water. So, material along with water in terms of slurry has combined and then started forming and then started moving along the surface. So, this is the parent material after getting mixed with respect to the water, which was primarily because of snow melt or prolonged rainfall. It mixed with water and this entire slurry has started moving downward along the slope. That particular kind of failure in landslide, it is called as flow. So, the rate of movement of displacing material, it is resemblance of viscous material. So, the soil mixed with water and it is flowing just like a viscous liquid flows, it is flowing downward from the slope. Again, it can be debris flow or mud flow depending upon the material which is in contact with the water and started flowing. So, rapid mass movement in which loose soils, rocks and occasionally organic material also combined with water to form a slurry, then flows down slope. That is the typical characteristics of flow landslide. At high water content, these slides may evolve in terms of debris flows. So, if water table is, if water is content is very high, even debris with the water starts flowing. The movement, typical movement which one can witness is 35 km per hour, that kind of movement. So, this is the movement of the slurry with respect to its parent medium which has been triggered during a particular landslide. Again, these are triggered by intense surface flow because water should be present there in order to get mixed and form the slurry. So, this is intense surface flow induced by heavy rainfall or snow melt. So, it can be because of rainfall, it can be because of snow melt, but certainly in this particular case there will not be any earthquake loading condition alone triggering, because you have to have some kind of water present, which can be because of snow melt or it can be because of prolonged rainfall, which is actually bringing the material, getting mixed with it and then bring it downward. So, landslide causes and triggering mechanism. What are the difficult causes you can see which can actually trigger landslide? Physical causes, intense rainfall. If the rainfall is intense, there will be formation of weaker plains through which possibly the failure may trigger. Rapid snow melt, again because of rapid snow melt, these will also, when the water because of the snow melt is also getting flowing along the material, that will also cause weaker plane. Earthquakes, they are going to induce additional loading condition in the slope, destabilizing the slope, and finally you will have landslide. Volcanic eruption, again these can also lead to movement of the material, or because of the vibration generated over there you can have some kind of movement triggering phenomena. Prolonged intense precipitation, rainfall is there, intense, or any kind of other intense phenomena which is responsible for triggering of weaker planes. Thawing, flooding, shrink and swelling, weathering, which can again responsible for detaching of same material or different material, but from its parent position and leading to or triggering to some kind of movement, whether it is undergoing rotation, whether it is undergoing fall, whether it is going movement along the planar surface, whether it is formation of the crack and subsequently separating. But each of these are the physical phenomena which physical causes which can trigger landslide. Human causes, excavation on the slope or its toe, that can destabilize a particular slope. Using unstable earth material for the construction. So, use unstable material for the construction, these will undergo failure and then leading to landslide. Drawdown or sudden filling of reservoir, because if you are going to do these activities very quickly, that will also lead to failure or formation of weaker planes through which the material will undergo failure. Deforestation, as we know, because of the roots it will hold the ground in its position, but because of deforestation these roots will not remain in its position. So, material will not be able to withstand in its parent position and will subsequently undergo failure. Mining activities also create lot of disturbance, as a result of which the material will undergo failure. It is relatively the cementation, aging effect, which otherwise would have provided material lot of resistance to movement, now will be lost. Machine induced vibrations such as pile driving explosions, leakage from water and sewage pipeline, because that will also cause continuous passage of water through the material itself, causing weaker planes. Then loading of the slopes, you put some surcharge, you start constructing on the upslope of the road of the slope, that will cause additional load on the slope and subsequently will undergo failure. Geological causes, weaker materials such as volcanic, slopes of unconsolidated marine deposits, weathered material, sheared material, these are the possible material which are relatively weaker and that is why may have undergone failure. Jointed or fissured material, because it is jointed or fissured material, there are more chances when it is subjected to any favorable condition, these will undergo failure. And then subsequently contrast in permeability. If there is contrast in permeability, you will certainly have weaker channels through which the material will start undergoing failure. Slowly, initially there will be movement of the soil and subsequently there will be creation of the channels through which the material, entire material above will start sliding. Morphological causes, tectonic and volcanic uplift, because these are going to create some vibrations, even change in the topography of the medium. Glacial rebounds, fluvial erosion, we have discussed in previous slides also, because of rivers there is lot of weathering and triggering mechanism, so that will also cause some kind of landslides. Glacial melt, water outburst, so because of melting of the glacier, somewhere near the downstream of that particular glacier, you will have accumulation of water in terms of glacial lake. At times these lake will also undergo outburst, triggering of slope failure or landslide. Erosion of lateral margins, deposition loading on the slope or its crust, that is very prominently visible in many a times whenever the slope undergoes failure. So, effect and consequences, effect on built environment, you can see damage to residential buildings, dwellings, because the ground undergoes failure, destabilization. So, that can also cause some kind of destabilization to the foundation and underground utilities also. Damage to sewer, water, electrical cable lines, because you never know on which particular side of the slope there is relative motion. So, there can be breakage in the electric and water pipelines if it is located along the slope. If it is downward, then by virtue of the material which is coming from the slope and getting deposited on level surface, that can even cause damage to these pipelines and electrical lines, even those are not located along the slope. Cut and fill material, which are generally used in road and railway construction, as well as collapse, which can happen along the roads, because whatever material you are using, it is relatively weak and prone to failure. And subsequently, rock fall may injure or kill motorist, pedestrian, and even trigger some kind of damage to the structures. So, submarine landslides, again, if these kinds of landslide happening beneath the ground surface, so downward movement of geological material from shallower to deeper regions of the oceans, if these slides are happening within the ocean. Major effect to the depth of the shorelines, ultimately affecting the boat dockings and navigation. When these things are happening, suddenly you will see there is significant increase or decrease in the depth of water column, which otherwise was used for docking of the boats and ships. Can trigger deadly tsunamis also, because the material which has undergone failure and falling inside the water bodies. So, actually it is going to disturb the equilibrium of water column, and that can also trigger at times tsunamis or similar phenomena. Then destructiveness or destructive to aquatic life such as fish and kelps, formation of landslide dams which are short lived, the failure of which can affect the area downstreams. So, these are typical effects which can be witnessed, whether it is on ground or it is in offshore regions which are happening, or even onshore regions, offshore regions also, which are happening primarily because of the failure of the slope and how the failed material is interacting with the environment around it. So, this is the overall objective, as I mentioned in the beginning, is to introduce the intended user of this particular lecture to get accustomed with the term of landslide. What are the different landslide, what are the material involved, what are the mainly triggering factors related to the landslide occurrence. Thank you everyone. We will continue with other topics in next lecture.